Thanks for stopping by the Koike blog video edition. And today I'm going to talk to Shane McMahon about our new Shop Pro, which we unveiled at FabTech 2017. And we have been selling like crazy, haven't we, Shane?
Oh, for sure. We've sold about 30, 40 machines so far, Chris.
Wow. And what are some of the features that people would be most interested in knowing about? I know one of the things you and I talked about was dual-side stepper drives, which is really unusual at this price point. Why is that of...
The reason why that's unusual is because obviously it's a cost factor.
Yeah.
I mean, these motors here, you know, they're a fair price. And on top of that, when you add the gearboxes and all the wiring and everything else that goes into there, you know, there's a lot of money that's not really seen that's put into the machines.
So what's the advantage of dual-side drives over just a single-side setup?
Over single-side? Okay, so what it is on a dual-side drive, you actually have 2 points of contact holding yourself. So you're a lot more rigid, and you can couple that with electronic motion also, and that kind of helps stabilize everything for you. Whereas on a single-side drive, you've got a little bit of telescoping going on. And what that telescoping does, you can see it obviously, this machine was developed and designed for, you know, artwork, smaller shops, you know, big shops if you want to put some of your production runs onto this, or if you've got to make a wrench or a tool or a flange and you don't want to tie up your big machine, they'll put this in.
Right, yeah, actually some of our customers were using this for some of the scrap pieces, then they get it off their big machine and they can fully utilize that.
And the thing with this, with the artwork machine, artwork is actually one of the hardest things to cut, as is anything with lettering. And the reason why is because you have so many juts. Take for instance, if you were doing like a flame. Each flame tip, you're going to want to go out, cut the end of the flame, and then from there you're going to bring it back. But the thing with this is, if you have a single side drive machine, you're going to go and you're going to have to slow down before you hit that corner. And the reason for that is because, like I say, you get a little bit of deflection in the beam. And that deflection will obviously carry through your part. Well, when you have a dual side drive, you can turn the accelerations up and you don't have to ramp down. You can basically hit that corner roughly, you know, for example, 360 inches a minute. Hit the corner and then right out and away you go. And what that does is that reduces the amount of slag buildup. If you could think of when you go into a corner and you stop, and just for even a split second or a tenth of a second that you're sitting there, and you're actually going to come back out of that corner. Every tenth of a second that you sit there, your plasma torch is running, and it's just burning and burning and burning into the material. I mean, we're talking very, very small fractions of a second, but on a piece of plate, 1600 degrees, you can really burn a lot of plate real quick.
Sure, yeah. Now you mentioned OxyTorch. This is actually available oxy or plasma.
Correct.
Cool.
Yep, and what we have actually is we've got a downdraft plenum. So if a customer has an existing machine with a water table in it, we've actually designed, if you see the way the slats are oriented, there's a couple things we can talk about on there, but mainly, right now what I wanted to discuss is the plenum. It's an oxy fuel. It's not just an oxy fuel. It's a downdraft plenum. If you're doing a lot of aluminum, or you just plain don't want to use water, some guys can't get rid of the water in their area. It depends on your EPA in your area. So what the downdraft plenum does is it slides up underneath all of this, and it's a direct bolt-on. So even if you have legacy or existing machines, it's an exact fit. Nice. You don't have to modify the table, nothing. You just put it in place and let it go. And what that does is, obviously with the oxy fuel, you don't want to cut on water, because when you're cutting on water, it creates all the gas, it creates a pocket for the gas to form. So basically what we'll do is we'll put an oxy fuel torch on there. We sell it with water table with an oxy fuel torch. We just have the customers drop the table down, the water level, basically.
Okay, cool. And what else did we want to talk about? Gear rack? Helical cut gears?
Helical cut rack and pinion on this. And what that does, basically, if you think of the way that a rack is made, so if you have a straight tooth, you only have really one tooth of engagement the whole time. Right. So when you helical cut them, you have a little bit more engagement. You have roughly 3 times the amount of engagement per square inch. You couple that onto a zero backlash gearbox, and what you do, you've got an excellent resonation machine. And that basically it's another little thing that helps all the little striations. Like normally you see a striation in a cut. A lot of the material that we cut on this doesn't show any of that at all. It's almost, I'm not going to say laser quality, but it's
pretty amazing.
It's pretty comparable.
Yeah. And these are big rails too. When
Yes.
in this price point, you don't see 25 millimeter rails.
Correct. These are similar to, as an industrial machine designer. I mean, we're not just a bunch of guys that are building these in a little shop here. I mean, we're obviously,
Right.
we've got a huge factory, a workflow process. We've been around for 100 years.
Right.
So, but we're a manufacturer of large industrial cutting equipment. So we put them spare parts on this machine, or we try to have, common components.
Right.
That way our customers, if you have an issue, we have a better chance of having that piece on inventory.
Right.
So what we do is these ways and rack, this is something that we would use on a normal, $150,000, $200,000 cutting machine. And it's all basically,
It's all on this.
again, it's on this little guy.
At this price point. That's
Yep.
amazing. And actually, you talked about off-the-shelf components. Another one that you had mentioned to me in the past was the e-stops.
Yes.
Now, rather than being proprietary, let me make sure I'm recalling this correctly. The e-stops here are off-the-shelf components, so if you have one that fails some year in the future, you buy a $5 part instead of
10 years
something.
down the road, I mean, you know what it's like for a manufacturer to keep parts around for 100 years. They just don't do it.
Right.
If you went to buy a brand new pickup truck, you wait 10 years, you're not going to be able to go directly to the factory and get that exact switch. Well, what we did was we used certain components off the shelf, and basically it's a component that's not going to fizzle out in 2 years. It's
Right.
these are like this e-stopping, for example. We use this on the machines we
All
make.
big
It's on
machines.
the machines that we purchase here that we actually do our machining process with
Yeah.
also.
So on the subject of safety equipment, we've got dual side e-stops. Tell me about that. Why did we decide to put them on both sides?
Well, we put them on both sides because if there's ever an accident, chances are it's going to happen near your gantry. And if you have an e-stop on the other side of the machine, obviously you're not going to be able to reach it.
Right.
And it's just going to do more damage, and it's probably going to get you locked in.
Got it.
So basically what we do is we put them on both sides. You have an accident, you can always reach it with,
From either side.
From
okay.
either side,
And there is a torch breakaway,
Yes.
right?
yes. That's basically
So-
like an e-stop too, but what that'll do, this will stop the machine. So if you ever have any parts tip-ups or anything else like that, so here we're worried about our hands. Here
Right.
we're worrying about that $10,000 piece of half-inch stainless steel that you've got on this machine. Again, that's one little wrong turn, one little tip-up. If you lose that, your whole plate's gone. I mean, at this point, we can stop the machine. The machine will actually stop itself.
Right.
And then we can just reset it, fix our problem, and then go back and then continue the cut, pick it up, and away we go. You've got no lost downtime, no lost production, and you got another happy customer.
Excellent. Cool. So are we going to cut anything today?
We can.
You want?
I've got some flanges in there. I got some, there's an anchor in there with a wheel on it if you want to try that.
Yeah, sure. Okay, let's
go
do
take a
that.
look. It's pretty easy to run this control, and again, this is part of the market that this machine was designed for.
Right.
You don't need to be a college-educated guy with 10 years of CAD experience. Basically, you need to know how to go on and find a good quality image or get a good quality DXF, and you can basically import it, and the software does 99% of the legwork for you. You got to know a little bit of math, and you got to know a little bit on how to draw with this software. But other than that, I mean, it's a 2-week learning curve. After that, you're ready to go.
Okay.
I mean, I'll just give you an example here. There's a DXF that we made for a customer, and it's just an anchor. It's
Like a boat anchor?
Yeah, like a boat. It's a boat anchor and a steering wheel.
Oh,
Actually, For
okay.
a boat. So I'll click on it here. I just imported the DXF. Click on the DXF that I want, and I'll open it. Now I'm going to let this do its thing here, and you can see the progress bar is done. You're ready to go. At this point, I am
Pretty fast.
That is a cut ready part. So what I want to do, I'll go over to my CAM screen, this is what actually initiates the machine motion. The CAD is basically a drawing software. This machine has its own drawing software, but you can use an external drawing software if you're familiar with AutoCAD Inventor or any of that across the board CAD or CorelDRAW or anything like that.
Sure.
You can draw your files in there and import them right into this machine. You don't even have to use this software. You can use what you're accustomed to. After that point, it comes into a CAM, which is it's basically command motion. And what we're going to do here, this is actually updating our toolpath at this point. I'll go ahead and let it run for another second. And what updating toolpath means is it's actually putting our lead-ins and lead-outs as we've specified in the machine into it.
Where the torch is going to start and stop?
Exactly.
In other words?
So
okay,
it's not just to start and stop though. What it is you want to be able to pierce into the part.
Right.
And then come out in, basically you're piercing in a dead zone and then you're coming out to your cut line. And what that does is that gets rid of a lot of the dings. If you can imagine piercing on a line, it's going to blow a little bit of a hole in there.
Yeah, yeah.
And then it'll give you a little bit of a run around.
Okay.
Basically, while we were doing that, this thing's ready to go. I could do a nest of 100 of them. I think we'll just start with one for right now. It's actually telling me also on the screen, you know, I've got a 12-inch wide part and I've got 12 inches tall here. So what I'm going to do, I'll bring her over and I'm going to run this. Let me turn my laser pointer on real quick. And that just gives you a little bit better visual, so you don't have to be right on top of the machine trying to figure out where your line is.
Nice.
Or your plate. It really helps for plate utilization. So I've got that on. I'm going to come over here. Let me get this magnet out of here real quick. That looks like a pretty decent spot. So from this point, I'm just going to set my coordinates, and I'm just going to press play. And the machine will do the rest of the work from there.
Nice.
Okay, now that we're done purging, let me go ahead and move this machine out of the way. Let me use my hand lifter here. Come on, go ahead and take a look at that, Chris.
Nice.
Now this is actually the bad side of the cut.
Okay.
I'll pull a rag out of here and show you what we're talking about. If you can actually look at this, a bunch of this stuff off of here, you'll see there's very little slag and dross buildup on the backside. And the reason, as you know, thin material, it's worse.
Right.
I mean, you have to be able to hit a certain speed range in order to be dross-free cut. Mm-hmm. And in turn on that, you've also got to be able to hit your corners fast. Again, you'll see here we have a little bit built up in the corners, but it chips right off. Mm-hmm. And that's pretty much it. From a side view.
Clean that up easy.
Like we discussed. I mean, it's not quite laser quality, but I mean, you know, for
pretty good.
$30-some thousand machine.
Right.
It's there.
That's excellent. Very cool.
And there's another added benefit of the water table. We can pull that right off the table and use it.
Very cool. So, if people are interested in more information on this machine, they can obviously go to our website, but they can also call you or email you, and we'll make sure that we have the information in the description down below. And thanks for joining us for the Koike blog video edition, and we'll have more information for you in the future that you'll find beneficial in your fabrication work. Thanks very much for joining us.